Okay, if you saw this on a quiz recently, it's because I thought I'd taught it to you yet, but I hadn't. So no, you might be able to know how to do it. So log base e of x is the same thing as this is read as the natural log. Well, there it is, natural logarithm. So whenever we write, so if I wrote a natural log of 8, that is the same thing as a logarithm, but the base is understood to be e. It's always e when it's natural logarithm. It's understood, kind of like when I write, we did talk about this before, log of 8, the base is understood to be 10. So if it's a regular log, the base is 10 if there's no log written. If it's a natural log, the base is e. And these are the two most common logs. The calculators used to only be able to handle base e, natural logs, or base 10, kind of regular logs, common logarithms. Okay, so you can actually solve problems, and the same properties and everything else kind of apply to these kinds of problems. So let's look at this problem. So let's say you don't know how to solve this. I'm going to say equals x, right? We're going to solve it for x. So you have to put it in the correct forms. You have to change the form to solve this. So so you say, well, the base is really e. So in exponent form, this would be what to what power equals what. So we just kind of put it in the right form. So this would be e to the power of x, because the exponent's on the other side of the logarithm, equals 1. E to the what power? E is like 2.7. It's a number in your calculator if you haven't seen it. So what I mean by that, do you see this e to the x button? So if I put e to the 1, it's 2.718. Kind of like pi is 3.14. That one is, e is, it's called Euler's number. It's 2.7. So it's like a number, 2.7, to the power of what is 1? Well, hopefully you know that just about anything except for 0 to the 0 power, so this is equal to 0, is equal to 1. So the answer is 0 there. This one, if you try to solve this, let's see, so understand the base is understood to be e. That's actually a property, just like that was a property, right? Log of 1 is always 0. It's the same property. Let's just pretend we don't know this. So I'm going to write x, and we're just put it in exponential form. So it'd be e, that's the base there, to the power of x equals e. Well, if e to the x equals e, what does x have to be equal to? Well, x has to be equal to e to the first equals e, right? So the answer is 1 there, just like the answer for that one is 0. Those are properties. Okay, so solve these equations. So again, you're going to change the form. When you're first starting out, it's just a good idea to go ahead and put the e in there. So it helps you change the form a little easier. So this would be e to the third equals x. That's the exact answer. If it was a no calculator section, that's the answer I'd want. If you're in the calculator section, you can hit the e to the x key, say e to the third. I'm going to put a decimal point so I get a decimal. So that x is approximately equal to 20.0855. Let's try this one. So this would be, again, kind of put it in the right form. So it would be e to the negative 4 equals x. That's the exact answer, but I don't like that answer because we don't like negative exponents. So I would rewrite that as 1 over e to the 4th. That's the exact answer. And then if you have your calculator handy, you can put a fraction template 1 over, and then just hit the e to the x button, e to the 4th. And you get x is approximately equal to 0.0183. So this one, you can't change the form right now. First, you have to use the law of logarithms, or the property that you can learn, and kind of compress those together. So those also work with natural logs. Remember, natural logs are just logs with the base of e. So they have the same base, so I can push these together. So I can say this is the natural log of 2x times 3, which is 6x, which is 2. Again, write the base so you see it easier. So then e squared equals 6x. You're almost done. You have to solve for x. Takes one more step. Divide by 6. You get x equals e squared over 6, or approximately equal to whatever e squared over 6 is. So e squared divided by 6. Put a decimal point so I get a decimal, which is about 1.2315, I think, 15. And this one, this should technically be in parentheses there. Okay, so I'm going to put the e there so I see it. So it'd be e to the second equals, this is a little tougher, x minus 3 squared. Now, what could I do to both sides there? Do you see a move you could kind of make here? So you could say, you could take the square root of both sides, right? Plus or minus on this side. So we get plus or minus e equals x minus 3. Add 3 to both sides, you get 3 plus or minus e is equal to x. Those are the exact answers. But you do have to be careful here. So let's think about this. So you can't take the log of a negative number, but that value is being squared in there. So I think both of those answers would be correct. So you could, yeah, so then you could just type in your calculator 3 plus e to the first. I'm going to put decimal just like a decimal, 3 minus e to the first. I think both of those would actually work in this problem. You get two different answers. It's kind of a tough one there to solve. And let's try these. So solving exponential. So again, the method on these, if they're in exponential form or log form to start, just change the form. So I'm going to put this into log form. So first I'll just kind of go into basic log form and then I'll explain something here in a second. So log of a number with a base of a number equals a number. Okay, so let's put all the numbers in the right spot here. So this is going to be the base is e. The exponent goes on the other side, okay, and this is 12. So the answer is x is log base e of 12, but no self-respecting mathematician would write it that way because the base is e. We always use a special notation, so we would probably write it this way. Natural log of 12 is equal to x. That would be the exact answer. And then we can type in our calculator with the nifty natural log button. So if you control e to the x, natural log of 12, if we wanted the decimal. And again, it just depends what we're asking for, exact answer or approximate answer, 2.4849. Again, since the base is e, I'm just going to, instead of going the halfway step, I'm just going to go straight to the natural log. I know the base is e, so natural log of a number equals a number. The exponent always goes on the other side. The number goes in the missing spot. The base is understood to be e, so it's there. One more step, divide by 3, divide by 3. You get, that's the exact answer, right? Natural log of 9 divided by 3. Oops. Natural log of 9 divided by 3 is, so x is approximately equal to 0.7324. Try these. So before I can put this into, I guess, natural log form, I want to move that over. I want to kind of isolate, get it into exponential form. So e to the 2x equals 10. Now I can do this. So it'd be natural log, base e, I don't have to write that, of a number equals a number. The exponent goes on the other side, and 10. And last step, divide by 2 to solve for x. That's the exact answer. You can get your calculator out. Natural log of 10 divided by 2 is x is approximately equal to 1.1513. And this one, again, before I start, I want to get it into exponential form. It's not quite there. So e to the 4x equals 8. Now it's in exponential form. I can change the form. So this would be natural log of a number equals a number. The exponent goes on the other side. This one goes there, divided by 4. You kind of have the same kind of pattern here. So that's the exact answer. If you wanted the approximate answer, natural log of 8 over 4, x is approximately equal to 0.5199, I guess. And that's your lesson. Let's go back and do the PSAT. I actually like this one. It's relating to what we're doing. What's the real value of this? Stop it, try to answer it. Of course, you're going to put this into exponential form. So this would be 5 to the power of 2x. Wait. I don't think we have to put it in exponential form. I think we can solve this. We can do a couple things. So one thing we could do is kind of move that 2 out front. So this is going to be 2 times log base 5 of 25 equals 2x. Divide by 2. Those cancel. Those two, the 2's are gone. So x equals log base 5 of 25. Hopefully you know what that is. If you don't, we can just change the form, right? That we're to the point you type into a calculator, I guess, if this is ACT. But the thought process, if you change the form, you'd see 5 to the x equals 25, 5 to the what power is 25, and you probably know that's the second power. And you can plug that number in, you see it would work. That's your lesson for today.